Hello guys, I am back. Let me just adjust. Today in this stream, we're gonna go about write some. In the last thing, what we were doing was like a little DSA sliding window stuff, and I was doing this problem called fruits in basket and couldn't really solve it. So today what I'm gonna do is like try to go through that and that's it, man. And after that I'll do some backend stuff. Today whatever it takes, I'm gonna complete this. So hopefully, mostly, yeah, I just got to at this point. So fruits in baskets. I mean, this is more of an explanation class, मतलब introductory thing. This is not, I can't even explain. This is more of like a learning, reminding myself what I have done so far. Mm, nah. Don't ever want it to end. If I have my way, I would never leave. Let me I've actually connected my pen. Now what I'm gonna do is like, yeah, then yeah, orange would be all right. So the question actually said, what the question says is find uh, longest subarray with two distinct elements. The question actually says you have like this garden and you have a bunch of trees. They are denoted by numbers. So one, two, three, two, three, one, one, two, four, something like that. Now we are supposed to find the largest string of numbers, the largest sequence of numbers with the condition. So what is the condition, sir? With only two distinct elements inside that subarray. So let's say 1, 2, 3 is a subarray, right? And 1, 2, 3 is not a valid subarray. It is invalid because you have more than two trees inside it. You have more than two types of fruits inside it. One is of type 1, the other one is of type 2, and the other one is of type 3. So this is invalid. So what this guy is asking for us to find is find valid ones. Valid. So the way to write sliding window code is that one of the things is that so 1, 2, 3, 2, 3, 1, 1, 2, 4. I've actually asked ChatGPT and I've seen two, three sources, and ChatGPT and some these sources tried to remind me, which I will try to uh, go through again. Is that when we start with a subarray, let's say if we start right here and like start increasing, start taking things into a subarray one, and after that let's say two, up until 2 it's fine, it's great. Let's say there is another 2 here, up until this 2 it's fine. um, but after that, after when we include 3, what has happened here is it's invalid. And after taking another number inside this, let's say 1, 2, 2, 3, 2, it's it doesn't become valid anymore. So you can't just go on taking in things, right, to make it valid. Once, once an array goes invalid while considering in values to the right, you can't make it valid again by eating more values. You have to shit something out. You have to spit something out from the bag. So this is where the I pointer comes in, right? So let me rewrite this by saying where the I pointer comes in. Uh, right. Let me change my color to violet. Yeah. So let's take two pointers I and j. मतलब just they start at 0, right? They both point uh, the first element right here. Yeah, index 0. So what should happen is we should increase j. The idea is to increase j until it reaches what, the end, right? Until it reaches the end, you increase j, right? You keep increasing j. So this goes to be like this: while j is smaller than nums, let's call it this nums dot size. The idea here is to run another inner loop. So that's that, right? Let me scroll this down. Ah, there we go. Yeah, the idea here is to simply arrays and all right, j plus plus, right? And once the 1 2 2 3 4 5 5 4 2 or something like that. All right, let's say this as j. hmm, Once you have increased your j from 1 to 0 to 1, well, before increasing, uh, you're considering a j, right? You're considering this one, right? You're considering this one, right? What we need to do, what the solution said, and which makes sense, is to keep a count slash like a hash map thing of of elements here. So let's say the tree 1 has come how many times up until now? 0 times before like the loop has started. Once the loop has started, what should happen is it should start taking things into account. So wherever j stands, include that into our hash map, right? Include that into our hash map. Let's say our hash map name is h map, hm, right? So what I'll do is hm, mm, yeah, uh, or let's say, okay, it's I want to go with dark orange, right? Hash map. Um, the hash map thing, what should happen is mm, hash map of nums of j. So the array is nums. The nums of j is 1. So 1 का count जो है, it should be first of all increased. I guess that should happen first. Okay, that is the first thing you will do. Okay, you will see whether without even seeing, you will first include that into our hash map, and then what I will do is we have a count k, right? Which is like it is 2, I guess. It is 2. Hmm, right? Hmm. What we could do here is you can run another loop while, but this loop, see, once we have taken in j, you want to see whether this is valid or invalid. This array is valid or invalid considering this j. So if this is valid, how can we check if this is valid or invalid? Is um, we we can run this while loop, not just to check, but to move I too. We can just simply use a while loop, right? So while what should happen is, let's say j is right here at 2. Yeah, j is right here at 2. What should we do here is we need to count the number of unique keys in the hash. So let's say the j is at 2. So 1 is 1 and 2 is also 1. So the number of unique keys here is 2, which is like all right, you know, we can have anything smaller than or equal to 2. So smaller than or equal to 2, hp dot count. So we'll count the number of keys. If it's smaller, if it's greater, you need to run this loop. If it's greater, what you will do is what you will do is you will first off you will what you will do is, if it's greater, you will first off take this one uh, of the hash map, right? Erase erase hp dot erase. This is a function where you can erase a key. Hp dot erase error of I, well, nums of sorry nums of I. You can take off that one, so you will cancel this one off. Let's just take a bad case, right? We are taking a really good case, pardon. So let us say this example, right? Also, I'll change this, keep it light. So one, let's say j is right here, j is right here, and the hash map would be like this, right? So hash map would have one, would have two, is twice, one is once, and three is once. This is invalid. So as this is invalid, the I is right here. When we enter this loop, we'll erase whatever is in HP. We'll erase the nums of I from the hash map. So this is erased, and after that you will increase I. You will simply increase I. So this will come to right here, and after increasing of I, what we should do? Yeah, you can simply increase I, and that's it. That's the end of the story. Now this is again 2 to 3 is again valid, right? You can simply increase the value of j, and now at this point we'll check again whether this we'll add this, and we'll check whether this is valid or not. So what is happening here in this sorry guys, there was a bug there, I had to remove that. Yes, the idea here is uh, for every j, for every j, for every j, you check. First off, you add them into map. Add them into map. This is pretty easy. I'm just trying to um, do it so many times just so that I get the general idea of this, general idea of how we can solve sliding window problem. Exactly. So then this while loop, what should happen is for every j, this while loop is gonna go for every j, right? So for every j, uh, I will first off add them into hashmash, and then check whether it's valid or invalid. I'll consider it, and then I'll check whether it's valid or invalid. That is what is happening right here, right? So let me write the code. I mean, I've written it once, I'll write it again. Code should go like this, right? Let me include left is 0 and left right is 0, and one should also make a hash map unordered or ordered map map int comma int, right? Let's call it hp, and what should happen is while right pointer is smaller than fruit fruit start fruit start size, where right pointer is smaller than fruit start size, we will run this, right? Yeah, and also I didn't really mention the thing that we had to return, right? I'm so sorry. So what we have to return is simply the max comma right minus left plus one j minus I plus one. So which is pretty basic, right? What we are supposed to um, return is the size. So we'll conclude the size after uh, saying whether it's valid or not. This is all right, I guess. We can do one experiment right here, which I'll do in a minute. So what should happen in this loop is we can simply increase the right pointer whenever we complete the loop, whenever we do an iteration. So uh, at starting of the loop, what should happen is HP HP of right should be increased, right? HP of right should be increased. That's it. Not just right. HP of right, uh, roots of right. Cause right is just an index here. Fruits of right includes the type of root. So that should happen. And after that, what should happen is simply this, right? You increase HP, then HP, you will write this while loop. While HP dot count, HP dot count. Let's how do in to do it like ages dot count 30. Okay, it's gonna count the number of that is contains, right? I want to dot size tells you how many total keys are currently stored. So what we want is size, right? HP dot size. So how do we use it? HP dot size. Yeah, ages dot size. Simply. All right, that makes sense. HP dot size. If it's if it's greater than two, if it's greater than two, what you want to do is simply um, what you would want to do is simply, yeah, if it's greater than 2, what you want to do is erase the ith one from HP. So erase fruits of I which is left, in this case minus minus, and you don't really need to let's ask how do we use erase in CPP. What goes in as arg? cpp.arrays key itself as the argument, right? You it has the key itself as argument. So makes sense. So roots of left. What is left here? Left is the index. Roots of left is the key. So roots of left is what we are trying to erase. hp dot roots of left erase, and after that, what you would do is simply increase the I, which is left. Still, you will simply move ahead with respect to left, and that's it. That's what I would do. And also I would need int m is 0 and int, that's it, I guess. Int m is 0 and m is max of uh, m comma right minus left plus 1, cause this is how you would find the size of the subarray, right? Right minus left plus 1, that would give us the count of number of elements in that subarray, and m is something which is like really small, and we would find the max of them, and that's how we would do it. And we would want to return m, and that's it. That would make sense. hp dot erase. Where did I uh, const iterator, reference to a non-static member? Copy paste it. Hey, Gemini take much time, bro. Incorrect, using square brackets for a function. Okay, that's what I did. What the hell? I'm so sorry. The function, right? How would I do it? Hmm, that should give us something close to answer, right? Yeah. Sir. Let's see. Let's see. 3331. 3331. So what would happen here is it includes 3, and it includes 3. In this loop, what should happen here is it would definitely include, oh yeah, it should include 3 and HP fruits of right. So 3 का count बढ़ जाएगा. The 3 का count would be 1, and no, this would work. So max would be 1 and right would increase as it should. It would happen again. HP dot size. I want to print. I can't write it like this. So cout HP dot size, right? I want to see what this is going to give me. I should have submitted it, right? Thank God. Hmm. Koba, Koba, Ko, Ko. All right, 1, and for this it's 1, and for this it's 1, and for this it's 2, which it should be like that. And for this, when right comes right here, what should happen is it would definitely increase to 3, because I am doing it right here. So it will definitely increase to 3. And what should happen is, let me cut this and paste it right here, and submit this again. 1. 1 1. Why is this not working? So mm, let me go through this again, bro. Let me go through this again. Um, what is this? So yeah, mm, 1 1 1. When it comes to this one, it would become 2, that which would make sense. And it would to this one, what will happen is I will increase, the left one will increase. Oi, oi, this is wrong. This is wrong. Okay, I got it. I got it. Where I was doing mistake was simply, mm, bro. What I was doing there was, see, the problem that I was facing was this line, especially the H, which I've deleted here. Let me try to scroll back. Yeah, this HP dot erase. Voila. So the problem there was you, whenever left is, let's say it's pointing to 3, 3, 3, 1. When the left is right here, if I start erasing 3 itself, what will happen to count of these, right? It won't make any sense. Um, so if I start erasing 3, then it would, start, it wouldn't go into this condition while, which is like while greater than 2, because I've just decreased the count in the hash map, so which won't make any sense, right? Like, I have increased from this, I have to erase something if the count is 0. If the count, if the, let's say 3 is thrice here, if this becomes 0, if 3 is 0 times in the hash map, then only then I have to delete it, only then it has to be deleted. So what I should be doing instead of that is, I will write the while loop like just like that. The while wouldn't change. And what I would do is simply minus it. Minus what? I'll simply decrease the count first off, which is like fruits of left minus minus, and then check if if it's 0, if the count is 0, this what if the count, uh, which is gonna, what would count to by the, so mm, uh let's not even use count, bro. Let's just use if uh fruits of left fruits of left is 0. If this thing, if the count fruits of left, yeah, in the hash map, if the fruits of left in the hash map is 0,